Hello, scholars. Welcome to this video where we're going to work through some time value of money calculations in a worksheet. So here's our equation. Future value equals present value times 1 with r to the n. And just to identify those variables for you, I'm going to put them on a timeline. If this is today at time 0, any amount received or valuing today is our present value. R, that's our compound or discount rate. FV, or future value, is what an investment will be worth in the future, and N is number of years or number of periods. So let's look at the first example, finding the future value. If you can invest 100 today and earn 8% interest, how much money will you have in 9 years? So I'll rewrite this equation. The future value at time 9, I like to put a subscript for time there, FV sub 9, equals present value today, subscript 0 if you wish, times 1 with r to the n. So future value at time 9 is just the 100 today times 1 with the rate times 1 with 0.08 to the 9th power. And I'll show you on your financial calculator how you can solve this. So if your financial calculator comes defaulted in this setting where there's only 2 decimals, you can change that by going second format, which is the spot button at the very bottom. Change that to 8. That's the most you can have. And then all the way at the top, press enter and then clear out. So now you have 8. So now add 1 with 8%. You have to move the decimal place 2 times if you're using a formula to solve with an interest rate. So that's 1 spot 0, 8. That's 1 plus 8%. And then hit the exponent here for y to the x, y to the power of what? It's prompting you for the exponent of 9. Then press equals, and that's your future value factor that you multiply by your present value of 100. So your future value at time 9 is going to be $199.90. That about doubled, and we'll come back to that in a minute. Now, how much will the investment be worth in 40 years? Some of you might have the right intuition that this is worth more because it's more time. So I'm going to just write FV sub 40 equals 100 times 1 with r, or 1 with 0.08 to the power of 40. We'll enter this in, 1.08 y to the x 40 equals, that's your future value factor, and then times 100 equals $2,172.45. So I've graphed that for you so you can see the power of compound interest here. It roughly is doubling every 9 years or so. And our final answer over 40 years, $100, a single saving is worth $2,172 over 40 years. That's pretty cool. So since we mentioned doubling, we can't mention doubling and time value of money without mentioning the rule of 72, which approximates the time required to double an investment. So I put time until 2x is approximately 72 over the interest rate. So I'll put time here. That's approximately 72. And the interest rate here is 8%. So 72 over 8 in percentage form is about 9 years. And in fact, that's what we saw with the problem before. We had 9 years, we had an 8% rate, and the future value was almost $200. So that was a doubling in 9 years. The next doubling you could expect to be around time 18 years from then, and you'll get 400 there. Thereafter, you can just see next doubling would be 16. Just draw as straight as line as possible. And you can see that holds approximately true. This only works for approximations, so don't use this rule if the question asks for an exact answer. But it's a kind of neat tool to use if you're reading a news article and you're trying to infer an interest rate or time to double. Now let's talk about compound and simple interest. Compound interest assumes you earn interest on interest as well as the principal. With simple interest, on the other hand, you only earn interest on the principal or the initial starting balance, that present value you invested. You could rewrite this to factor out the present value, and that would be present value times 1 with Rn. but either of those equations will do just fine. So if you had a relative deposit $10 and we're computing for simple interest, your present value is 10 times 1 with R. And again, we're using a formula on this, so we're going to move the decimal rate. So 0.055 times 200. So 0.055 times 200 equals 11 with 1. 200 times 0.055. 11 with 1 equals, and then times 10. There we go, 120. Your future value is only 120. I always double check that one because it's surprisingly low every time I do it because I'm so used to doing compound interest. So let's look at compound interest. Your future value is your present value times 1 with R to the power of N. So your future value here is the $10. This is really going to make you wish you had this relative times 1 with 0.055 to the power of 200. So combining those, it's 1.055. Y to the x for the exponent there, 200 equals 44,000 is your factor. Multiply that by 10, and you'll start to see why you wish you had that relative. Future value is $447,189.84. So that's the difference between simple and compound interest. If you got a question that said, how much more could you compound how much more could you earn if you're compounding interest as opposed to just earning simple interest? It would just be the difference of those two numbers we calculated. We're going to do one more question just using the formula, and then after that, we're going to use the financial calculator. So let's find the present value. If we rearrange our future value equation, I'll show you how you can get to the present value. You're dividing both sides by this factor, 1 with R to the n. That will eliminate on this side, just be 1 there. And then over here, you'll have 1 with R to the n. And if we clean this up, you'll just see that the future value equals, your present value equals your future value over 1 with R to the n. So let's rewrite that with present value on the other side. Take a look. So your present value is your future value over 1 with R to the n. So that's 10,000. Over 1 with 7% in 1 year. So that's just 1.07. Anything to the power of 1 is itself. If you're dividing by this, you could also take its inverse and then just multiply by 10,000. $9,345.79. The lights in my office keep going in. All right, so numismatics is the study or the collection of coins. The 1893 S. Morgan silver dollar sold for $200 in 1950. Then in 2021, it sold for $180,000. What is the compound rate on this coin? So now we're going to do a financial calculator approach. N, IY, PV, payment, and future value. This whole row of buttons works together. So if I, again, copy down that timeline that we worked on, you can see your present value is here. Your R is what your calculator calls the IY. And you have present value, the amount invested today. So it's the initial value of the coin. The future value is what the coin compounds to. And N is number of years. So let's fill this out. Time, this is a little bit tricky. You have to find time, and it's the year 2021 minus 1950 for time. You're solving for rate. Your present value is given. You have to specify that this is negative. Imagine you are paying for that coin. You're paying $200 in 1950. And then the future value is the expected return of positive 180,000. If you ever get an error doing these types of calculations, the typical solution is to set the present value negative. Payment is 0. This coin is not paying you a coupon payment or a dividend or anything like that. It's just a single cash flow. of $200 at one point with the expected return there of $180,000. And your rate is what we're going to compute for. So to do this, all you have to do, calculate the years, 2021, less your 1950 for your 71 years. That's your N. So you're typing in the number, 71, and then pressing N. 200, make sure you specify that that would be a cash outflow, so specify that as a negative PV. Positive future value of 180,000. There's no payments between now and then. The coin's not paying you anything. And then you compute in the upper left and then press IY. So we specified the other four variables and we're solving for the missing IY, or interest per period. That will come out to 10.05% per year. Pretty decent compounding return. Now we'll find the number of periods. Again, I like to use the financial calculator on these. It just makes it a little bit easier as opposed to dealing with some fractions in the exponent or natural logs. So in this case, I'll just write the 5 variables on our financial calculator: N, IY, PV, payment, and future value. You want to purchase a new car, you're willing to pay $20,000. You can invest 10% per year, that's our rate, and you currently have $15,000. Now with this rate of 10%, your financial calculator knows that if you enter 10, that it's a percentage. So there's no need to move the decimal like we did when we used the formula. Your future value in this case is $20,000. So imagine you have an account, you'd have to contribute or forego the use of $15,000 today. So you could specify a negative present value of $15,000, positive future value of $20,000, and there's no contributions into that account or out from that account. So payment is going to be specified as 0. There's no additional things along the way. And then we're going to find N. So you press 10, then press IY, 15,000, make sure that's negative or you'll get error 5. So to do that, on the bottom row of your financial calculator, there's a plus minus button, and then PV, 0, then payment, 20,000, then FV, and then compute for N. This is 3.02 years. Once the cash flows start to get a little bit more complicated in the next unit, you'll see why it's helpful to have a financial calculator, because solving for N and IY would be extremely difficult once we introduce annuities. All right, doubling your money. Suppose you're offered an investment that will allow you to double your money in 6 years. What is the exact implied rate of interest? This word here, exact, means we cannot use the rule of 72. So in this case, we're going to have to just make up some numbers to get to an answer. We're trying to find out how long it takes to double. So we just have to make up something, say negative $1 million to receive positive $2 million in the future. The time period is 6, so my N is 6, and then I have everything I need. So 6, and then N, negative 1 PV, so 1 plus minus for a negative 1 PV, 0, then press payment, 2, then press FV for future value. So 2 is double 1. You could have also have done, negative 10 and positive 20. You'd still get to the same rate. And then just compute for your IY, and you'll get 12.25%. So when you have to compound over long periods of time and you're doing math, it's best to be exact. But if you're in a meeting and you have to make a quick estimate, you could use the rule of 72. In this case, time is 6. 6 is approximately 72 over what? You would just cross multiply there, and take 72 over 6 is approximately 12. So 12 is an estimate. It's not the exact rate. The exact rate is 12.25. If you're actually compounding, you'd actually want to make sure you account for that additional 25 basis points, or 1/4%. Understanding the relationship between time and present value. In class, we talked about this relationship. Let's show that it works now. Let's look at a couple scenarios where we're each going to receive $100. In one case, we're going to receive the $100 today. So if $100 today is received today, that's just worth 100. There's no math needed to do. That's worth 100. We're going to look now at changing time. in solving for present value. So in this case, we'll find n of 5 versus n of 10. There's no payments along the way. We're just considered a future value of 100 in each scenario. The rate is fixed at 6%, and we're just going to compare different present values. So again, the first scenario, that present value is just 100. Our present value for the next one, if we type in 5 and then n, 0 and then payment, 100 and then future value, 6 and then your rate, and then just compute for your present value, you'll have 74. 73. So you can already see if you have to wait longer for your money, you're less well off. That present value is now lower. Next, all we need to do is change the time to 10. So 10, then n, and compute your present value. The rest of the numbers will stay in there. This is saying you'd have to pay $55.84 today with the expectation of having an investment return $100 in 10 years. So some of you may have thought about this from a formulaic standpoint. If you did, you're looking at this equation that your present value equals the future value over 1 with r to the n. And you said, hey, if time is going up, if this is increasing, the denominator is getting bigger. And if the denominator is getting bigger, we're discounting by more, the whole expression will come down. Others may have just said intuitively, hey, I'd rather get paid today. That's more valuable to me. Waiting 10 years for $100 is less valuable. So either way you could get there. Just try to train your mind, not only in answering a specific question, but trying to think through a problem before we solve it. So let's get to this conclusion. Holding all other variables constant as time increases, which means as you have to wait longer to receive money, the present value of a future cash flow decreases. So that would be a qualitative type of question. You could use quantitative math to solve for that, or you could try to practice and see if you can get there. All right, let's understand the relationship between interest rates and present value. This is a really, really key concern for finance professionals. For now, I'm encouraging you to think of the interest rate as some kind of proxy or measure of risk or uncertainty. So if future cash flows have more risk, then we value those cash flows with higher interest rates. In class, we talked about this. Now we're going to try to show that it works by comparing the present values of several scenarios. So I'm going to solve for present value. In each case, I have a future value of 100. So I'm going to make a little table here. There's no payments along the way. It's just comparing a present value and a future value. My interest per period in the first case is 0. Then it increases to 5 and then 15, and time is 10 in every case. So we hold in finance typically one variable, each variable constant except for one, so we can understand its impact on the other. So here we're concerned about present value. Maybe it's a stock value, maybe it's a bond value, whatever. So to understand what drives that value or what contributes to it, we hold all other variables fixed. So our future value is fixed at 100, our is fixed at 0, and our time is fixed at 10. That's what I mean when I ask holding all other variables constant. That's what that factor means. This way we can see, hey, rates are going up. What can we expect happen to valuation? So let's do the first one, a future value of 100 with no payment at 0 rate and 10 years will compute for that present value. There's no discounting or anything there. The discount rate was 0, so we're left with 100 present value, 5, and now that is your IY rate, and we'll compute in the upper left our new present value. It's 61.39, and now we'll compute for, now we will change the rate to 15 and compute for a new present value, and it's all the way down to 24.72. So in every case, we are increasing our interest rate. It was going from 0 to 5 and then from 5 to 10. In each scenario, the present value decreased. So it leads to a very important relationship in finance that at higher interest rates or higher, in our case, discount rates, at higher discount rates, valuation or present valuation decreases. Think of it on a little teeter-totter there. So this is decreases is our answer. I was reading this article recently by Warren Buffett. He said, I got my $114 together by the time I was 11, but I enjoyed saving. I enjoyed investing. Buffett bought his first stock at age 11 with 114 in 1942. He didn't put it in the S&P 500, but he said if he had invested that in the S&P 500 index and reinvested the dividends and just let it sit, he'd have 400,000 in 2018. So what was the compound rate? So I read this article and had to do the math on this. So in our case, again, time might be a little tricky, but let's work at one variable at a time. Our present value was an investment of $114. The future value compounded up to 400,000. The payment there was 0. He just said he's investing the 114 one time and nothing else along the way. So your Y is what we're going to solve for. Time here, you just have to calculate as 2018 minus 1942 to find a new IY. So let's do that. 114 outflow, make that savings. So for